So I've never actually made this part before for the optional section of this paper. I'm going to try it with this video and it will help you because you can see my thought process throughout it as well. It wants us to make our T9 vehicle for the passenger base such that if we change the overall width of this part, it'll scale everything down for this part on the mini version. So that means that the overall width should be our target dimension that everything else, all the other functions are based off of. And we're going to make that D0, so that's going to be what we start with. And then it says the edge round radius, that anything that's curved over here on an edge is not dependent on this number or on these equations. It's actually the tools they're using to cut it. So that's also going to be constant. Then it gives us another clue that the holes for the connectors, right, so the little things that allow the connectors to join the body together, are identical on opposite faces, and all holes for the passenger and for the connector inserts are assumed to be centered on the part faces. So that means, hey, we can use geometric constraints. Cool. So let's scroll down and see what we have to work with. So dimensions that we have given to us, it says that the overall width is not a very nice number. It's 3.2. If we want the overall height, the 1.5, to be a ratio between the two, then it gets a little bit confusing. So I thought first I'd show you how I'm thinking about this. So let's ignore these numbers for a second and think if D0 was our target and D1, our overall height over here, was going to be 4. Okay, so that would mean that D1 is always going to be 2 times larger than D0. But it also means that the ratio between the two for D1 is 4 over 2 times D0. Well, let's say the ratio between them is 4 over 2, which is equal to 2. And so then we get our D0 times 2. Alright, we don't have as nice of numbers here, but scroll up to the top of this. In this case, we have D0, it's our overall width, which is 3.2. D1 is overall height, right now it's 1.5. So the same thing that we did down here with D0 times 2 or D0 times 4 divided by 2, we're going to have D0 times 1.5 over 3.5. The overall height, our target dimension here, or I'm sorry, the D1 dimension divided by our target dimension. Okay, so what that looks like on paper is if we draw out a rectangle, I make this dimension first, so this is my D0, then this is going to be D0 times 1.5, which is what we wanted it to be, over 3.5. Perfect. Okay, the fillets on the edges here, it says this is part of the equipment that they're using to make it, so we can make these as exact numbers. This is 0.3, and that's for all of our edges. And now we're ready to extrude this back. The distance on this, the overall width was 3.2, the overall depth is also 3.2. So we're just going to set this equal to D0. Let's make a new sketch. For our new sketch, we're going to make a hole for the connector piece. And it already told us about that it's going to be centered both vertically and horizontally. So let's make a horizontal geometric constraint with the centers of these, and a vertical constraint with these. And now our target dimension is 2.4. So again, it's going to be, and looking back at our example, our target is, it's going to be d0 times whatever number they want us to have over 3.2. So d0 times 2.4 divided by 3.2. The height of this is 0.95, so it's going to be d0 times 0.95 divided by 3.2. And then the fillets on this, again, this is the whatever equipment that they're using to create this. So it's out of our control. And this is not going to be 3. These should all be, what is it, 0.2. Okay, and it changed all 4 of those at the same time, so that's good. Let's extrude that out. We are cutting this, and the distance that we're cutting it is shown here. It's 0.55, so it's going to be d0 times 0.55 divided by 3.2. Okay, the other side is going to be an exact copy, so let's make a new sketch. Let's project the geometry of the other side here. Finish our sketch and extrude this, and it's also going to be d0 times 0.55 divided by 3.2. Good. For the top of this, we're going to make a new sketch. We're going to make another 2-point rectangle, and it told us everything is centered, right? So we're going to use a horizontal constraint, find the midpoint of this and the midpoint of our rectangle, align those, use a vertical constraint for the midpoint of this and the midpoint of our rectangle, and then it wants us to be 1.6. So that's going to be d0 times 1.6 divided by 3.2. The width of all this is 2. So it's going to be d0 times 2 divided by 3.2. And again, the fillets used on these are going to be dependent on the machine. So that's a 0.2 fillet, and that's all the way around. Okay, let's extrude that out, and it says this is 1.1. So the distance that we are cutting this is going to be d0 times 1.1 divided by 3.2. Okay, they don't have the little notches on the side of this like they did on the ones we made back when we were first learning how to use Inventor. So I think we actually have all of the dimensions right now. All edges are rounded, unless otherwise. Okay, all edges are rounded to 0.02 inches, unless otherwise noted, and that's all the way around any edge. So let's go back and make a 3D fillet for 0.02. We'll hit up all of our outside edges. I don't think we're going to get the inside edges. That wouldn't make any sense. So let's hit apply. And now we need to take a closer look at this. And it looks like, oh, I don't know. They don't do very well to show us how big this actually is, do they? Looks like that's 8 1/4, and this is about 4 1/2. Okay, so if we go back into extrusion 1, we want to change this. Let's see here. What is 8 1/4 divided by 4 1/2? Alright, so here's a calculator here. We had 8 1/4 and what we say, 4 1/2? 8 1/4, 4 1/2. So let's say 4 1/2 divided by 8.25. It's going to give us 0.54 something. So let's take this number and we're going to take that times 0.55. I'm rounding up. Okay, so now that becomes smaller. Everything else becomes smaller. And when I finish my sketch, it should all shrink down to a mini size. And now you should be able to go in and find your dimensions on here of whatever it's asking for with volume, surface area, and mass. Make sure with mass you're giving the right wood type. It says material is birch, so you would have to come in. I can't see with it zoomed out like this. Here, where it says generic, make sure you get this down to birch wood and use that to help find your solutions. That should be it. If you find that something is not right with my calculations, please let me know.